We're still learning something new about what we
We
already know.
were doing implicit differentiation, so would we consider this to be an implicit equation? Yes. Even if you solve for y would end up depending on itself, so that is an implicit equation. So how did we find the derivative? We simply start taking the derivative on both sides, but keeping in mind that anytime we take the derivative of y by treating it as x, we multiply by y prime. So chain rule on y. So we have to take the derivative of each term. Some of you are still making the mistake of writing this as dy over dx. It's just d over dx. Good. So 2xy plus xy minus y squared equals 5. If that is confusing, if you go to differential equations, you probably see this. You can just call it as uppercase G, right? So all you have to do is write it as this is the same as saying d of 2x squared plus xy minus y squared equals d for 5. I don't want you guys to do or write it as dy over dx because that is simply paving the way for disaster because you're not going to get the correct answer. So just do d over dx. We can distribute it, and if we take the derivative of the first term, it's just 4x. I'm going to write that as is, because I have a reason. If I treat y as x, what is the derivative of y squared? 2y. But then you realize it's not just x, rather it's just y, so you multiply by y prime. Good. Y prime, dy over dx, same thing, being effective. Efficient, so y prime. Fancy word for being lazy. So derivative of 5 is 0. So d over dx of xy.
Y plus x dy over dx.
Yes, but some of you did this. 1 times y prime.
Excuse me, what?
Exactly. So life is not that easy. This is wrong. Why is it wrong?
Because you
Go ahead.
Because when it comes down to it, this is one, this is multiplication, so you use product rule. 2, what they're trying to apply is they're trying to apply the thing that we do with addition and subtraction, where you take it into different terms, when that isn't going to apply here, because again, it's product rule, it's multiplication. That's as if you're trying to say you're going to fix the car at the same time while you're driving it. That just doesn't happen.
They just took the derivative instead of particle.
Yes, that is correct. So we have x multiplied by a function of x. So we have to use product rule. We can't just take the derivative of individual terms. It's like saying I have x multiplied by cosine of x, and I'll just take the derivative of each function separately. That's incorrect. So we have to use product rule, and we did use product rule last time for that particular expression. So you should have it. Xy prime plus y minus 2y y prime equals 0. And we want to solve for y prime, so I'm going to group all terms with y prime. Keep it on one side, move everything else to the other side. So x y prime minus 2y y prime will stay on the left-hand side, move everything else to the other side, minus 4x minus y. What do I have in common? Y prime. If I pull that out, I would have x minus 2y equals minus 4x minus y. Divide by y prime on both sides. Excuse me. Divide by x minus 2y on both sides. Yes. If you want to get rid of all negativity, multiply and divide by -1. You will have 4x plus y in the numerator. -1, if you distribute it in, you'd have minus x plus 2y, which is 2y minus x.
The question is, would it really matter if we left it as a negative? Would that be proper?
Doesn't matter.
Oh, I have two
I
questions.
just don't like negativity, that's all.
And okay, just for clarification for where it goes like 2y and y prime, like all the way back there. Yeah, like that, that number, well, you get it because you take the derivative of y, but since it's y, it's with respect, it's like the derivative of y with respect to x, so it becomes its own entity, right?
Yes, change.
Okay, right, I don't look at it as chain rule, it's kind of weird.
It is changeable because y is a function of x, right? Anytime you have a function of a function, right? So if this is saying f of x is equal to x times y, right? But you can't just cancel out the y, that's a bad example. But y is a function of x. And since it is a function of x, you are treating this as x. But then you realize that it is a function of x, so you multiply it by
So it's kind of
zero.
kind of like a substitution, so let's say it was b or z for like, then you would do the same thing because it's not x, but you would only treat x like in that way.
Exactly.
And my second question is, let's say we, like, what would happen, like, let's say we get this and they wanna add a point. Like, would we ever get a question like this and like, could we apply like a limit to it?
What do you mean at a point?
Like, can we apply limits to this?
A limit to it? Why do you want to limit?
That's what I'm asking, I'm just asking.
Sure. But
But what would it look like?
take the limits on both sides. So you can either take the limit for just x, or you can take the limit for both x and y. So for example, if you take the limit for x, which is, let's say, approaches 0, so that would become 0, that would become 0. So you would simply get the answer as 1/2. Yes.
How do you go from negative to positive? That's minus 2y.
I multiplied and divided by -1. Yes.
I don't really know where I did it differently, but I didn't have to do that last step with the negative. -4x minus y. I didn't have to
We
do
just did that first in preface.
So you got this without doing that, or you got that without doing
Yeah,
that.
I got that.
You probably move things around in a different order. That's probably what's it is.
They're still equivalent to each other, so it's fine.
Okay, so we want to treat all of x, y as just x.
Thank you.
If you think of x, y as x, what is the derivative of cosine x, y? Negative sine x, y. But then you realize it's not just x, rather it is a function of x. So you multiply by the derivative of x, y. Yes? what is the derivative of xy with respect to x? We did this in the last problem and the one before.
X, Y prime plus
That's y. Good. Left hand side. Right hand side, derivative of 1 is 0. Derivative of sine y, if you treat y as x, is cosine y. But then you realize y is not just x, rather as a function of x. So you multiply it by its derivative, y prime. Again, whether to write it as dy over dx or y prime, it's entirely up to you. I like y prime because it's easy. Now, some of you did this. Distributed that xy and wrote it as x squared y prime plus xy squared and put the sign up there.
If that was an idiotic.
That is incorrect. If this is confusing, think of it this way. This is one term in and of itself. That is another term. And if it's still bothering you, those two are in product. So you can just move that to, you can reverse the order. So since that is a term, I'm going to distribute it in. But I'm going to reverse the order so you can understand it better. A trick to not make mistakes is to always write whatever term that you have after a trigonometric function in front of the trigonometric function when you multiply. So instead of having y prime over there, I just switched the order, wrote it that way. If I distribute xy prime minus sine xy, if you multiply, I would have minus xy prime sine xy. Multiply those two, y times minus sine xy minus y times sine xy. Good. And you have y prime cosine 1. We want to solve for y prime, so move all terms that have y prime to one side, leave the rest on the other. So minus y sine xy would equal y prime cosine y. Move that term to the other side. Now we have y prime in common. So if I pull y prime out, I will have cosine y plus, I take the y prime out, so it's just x multiplied by sine xy. Good. I want to solve for y prime, so I'm going to divide by that term on both sides. So y prime would equal to minus y sine xy divided by cosine y plus x sine xy. So let's start with the left-hand side because it's very easy. From last time, just xy prime plus square root, plus y. Right-hand side, if I treat, well, before I proceed, let me rewrite this as x squared plus y squared raised 1/2. if whatever that is inside parentheses is just x, what is the derivative of x raised to 1/2?
That's going to be 1/2 x, which x is representing that, to the power of -1/2. And then we're going to take the derivative of what's inside of x. So inside of this case, x squared plus y squared. What's going to end up happening is that we're going to have 2x, and I believe it's going to be 2y times y prime.
Do we follow that? No.
No.
Take the derivative. Did we follow this then?
Okay.
Yes. Now we want to take the derivative of inside because we have a function of x. Derivative of x squared, 2x. There is a y squared inside. Y squared is a function of x also. So if you just treat that y squared as x squared for a second, then y derivative of y squared will be 2y. But then you realize it's not x, rather y, so you multiply by y.
Because you're treating as if you're doing chain rule within chain rule.
Yes, chain rule within chain.
Chainception.
Exactly. Y prime is probably Leonardo DiCaprio.
Never go to. That isn't the quote.
So I end up having this term, so 1/2. Move that to the denominator, x squared plus y squared raised 1/2. Good. Times 2x plus 2y y prime. Good. This
Yeah.
1/2
Okay.
all of that. Let me sort out, and we want to solve for y prime. So this big term right here. So 1/2 square root of x squared plus y squared multiplied by 2x, distributing that term in, plus 1/2 square root of x squared plus y squared multiplied by 2y y prime. Good.
Wait, you have to.
Distributing that inside.
Oh, because you.
This term multiplied by 2x, this term multiplied by 2y.
Okay.
On the left hand side, I have x y prime plus y. Good. The 2's will go away. Good. Move all the y prime terms to one side, the others move it to the right hand side so that we can solve for y prime. So x y prime minus y prime divided by square root of x squared plus y squared. Yes? I'm moving this term from the right hand side to the left. I'm going to move the y from left hand side to the right.
If you really wanted to be complicated, we could also just.
You know, make it more complicated.
I'm happy where I am.
Good, yes.
Why does it become x over x squared?
Yeah.
Why is it?
It-
not just- Yeah, why is
Because
it?
there is
Oh.
x. Do we have a y prime in common? Yes. Right hand side.
That's kind of fun.
Divided now.
Good.
Or flips, or not flips.
Now, I can take the common denominator. Do you agree? What do you make of that?
Stressful.
Stressful? Why? Did we follow up to this part?
Oh, no, I got
Wait,
it to
why
here.
is it- Why is it minus one?
Actually, never mind, I know why.
I moved, thank you, right. So if I took the common denominator, there is an easier way to do this, Paul. I'm just waiting for it.
First gotta drag.
Y prime, I can rewrite it as x square root of x squared plus y squared. Common denominator, right? I'm combining this with that. Do the same thing on the other side. I will have x minus y square root of x squared plus y squared divided by square root of x squared plus y squared.
Basically. what-
Common denominator.
Yeah.
And combining this fraction with that particular expression one. What do I have in common on either side? Go ahead, John, what's that?
No, I'm wrong.
What do we have in common on both sides?
He multiplied both
Divide.
underneath the x and the pretty much invisible divided by one underneath it, right? So he applied it to both the numerator and the denominator of the other one to make them like. That way he could just write it all as one.
So all I'm doing here, Ali, is I'm trying to combine this expression with that. What is the common denominator? Square root of x squared
Right,
plus y
just put it all
squared.
together.
Multiply and divide by square root of x squared plus y squared. I will take that. I guess I'll write it for the left hand side. If I multiply and divide by square root of x squared plus y squared,
I thought you just canceled that.
Keeps on going.
write this on the side. I'm trying to explain how we got.
Oh.
So on the left hand side, multiply and divide by square root of x squared plus y squared. I get that. I can combine those two because it's a common denominator. So common denominator, combine the numerators. So x square root of x squared plus y squared minus 1. So side step. So the final answer, can I read?
Wait,
Divide by that term on both sides. So y prime is x minus y square root of x squared plus y squared divided by x square root of x squared plus y squared minus 1.
wait, how is I didn't see the step before that last part.
That wasn't
Just
a step,
explaining
I
how
was
you
just
got to
explaining how
Oh.
to go from here to there.
Oh, okay, my fault.
Yes.
So why did you cross them out on the bottom?
So you have one rational expression here, one there, identical terms. So if you had x over 3 on one side and x squared over 4 on the other side, excuse me,
Over.
x squared over 3 on the other side, what do you do,
They're both the same.
right? Yes, multiplying by 3 on both sides, same logic, I'm multiplying by the common denominator and getting rid of it. So that's the final answer. I was not close.
is easy to, I'll be honest, I thought I was crazy for even thinking of anything like that.
So this is great and all, but here comes the big but. Can I erase this?
Not the last part,
Yeah.
How about the third?
definitely.
You can erase the floor.
So before I start, this is what I'm going to do. You know, if at all possible, we want to get rid of the radical, correct? So how do I get rid of the radical? Square on both sides, right? So I will have x squared, y squared. That would equal to x squared plus y squared. Yes? Move y squared to one side. Yes,
So,
y squared. If you take it out, you have x squared minus 1, correct? On the other side, you simply have x squared. Look me so far,
no,
why not?
so why did you do x squared times y squared?
I'm trying to get rid of the radical, so I'm squaring on both sides.
Oh, okay, I see that, I'm sorry, it's just there wasn't any parentheses or anything, so I thought you just suddenly morphed it into that for no reason.
I'm still.
Good so far? Yes?
He's trying to make it equivalent on both sides, so he's getting rid of the radical first by squaring both. Right, and then from there, what he does is he just generally solves.
So I got this, correct? What is the next step? But before that, though. No, take the square root on both sides. Y is simply equal to the square root of x squared over x squared minus 1. The only time when you can split a square root, or 2 times, is when you have a division or multiplication of terms. You cannot split a square root. Suppose you have square root of a plus or minus b. You can't write it as square root of a plus or minus square root of b. Make note of that. So, what is so different about that approach? Well, how right? So I can split the square root. So the numerator would simply be x. Denominator as x squared minus 1.
That's the answer.
Huh?
That's the answer.
No, that's just y.
Oh. Wait, and then you just take the.
Oh,
Right.
oh.
I didn't get any of that.
Do we follow that part?
No.
All I did was rewriting the expressions. Yes,
How did I get why the square root of x squared is x, but how is the square root of?
no thanks, I just forgot. Bad answer. Great. Now,
So next, what we have is we have y equals to square root of x squared.
so all I did is I squared on both sides, got rid of the radical, rearranged the terms so that I can solve for y, and I solved for y. Right? Y is purely a function of x.
So in this case, if, because again, usually when it comes to these implicit deviations or such, we're just looking to say y in terms of x.
Yes, if at all possible. So in this problem, I can represent y entirely in terms of x, unlike the other problems, where no matter how hard you try, y depended on y. Here, with that simple trick, squaring on both sides, I was able to rewrite y purely in terms of x. Yes. I can easily find the derivative of that term.
I don't know, yeah, because we could use chain rule.
Changing. What is the derivative of x over square root of x squared minus 1? How do we get it?
We're just talking about you get b prime very easily with chain rule.
True. U is x. V square root of x squared minus 1. U prime 1. V prime 1/2 x squared minus 1 raised negative 1/2 multiplied by the derivative of inside, so you get 2x. Good. The 2 and the 2 will get cancelled. You can move that radical to the denominator. You will have x over x squared minus 1 raised negative 1/2, which is x over square root of x squared minus 1.
It would be negative.
Yep, with that.
If we want that now, it's
1/2.
moved, right? In the denominator. it
Oh,
can't
I
be
see.
negative.
Okay. Good. U, V, U prime, V prime. I'm trying to find the derivative here. So don't erase this. Y prime will now be V U prime minus U V prime divided by V squared, quotient rule. So V U prime is 1 minus U is x. V prime is x over square root of x squared minus 1. Divided by V squared, square root of x squared minus 1 squared. Good.
So we have square root of x minus 1.
So we rewrote y in terms of x by itself. I'm finding the derivative of y using quotient rule.
And that then is divided by. Square root of x, what do you literally just have at the bottom? X squared minus 1.
Patience, I'm getting there.
Oh, I'm sorry, I thought you were getting on to the next question.
So the denominator, the root and the square will get cancelled.
And
Yes.
then at the top, what you have is.
Numerator, you have square root of x squared minus 1 raised 1/2 minus x squared over x squared minus 1 raised 1/2. Yes? How do you combine those two? Common denominator, which in this case, x squared minus 1 raised 1/2. So x squared minus 1 raised 1/2 times x squared minus 1 raised 1/2 divided by x squared minus 1 raised 1/2 minus x squared over x squared minus 1 raised 1/2. That's just the numerator. Yes? Divide the entire thing by x squared minus 1.
Is it fair to say I don't like either way?
Huh?
Is it fair to say I don't like either way?
I definitely think the first is less painful.
So, but we're guessing there. So what is the common denominator in the numerator? It's just x squared minus 1
I think that right now.
raised half.
Yeah.
If you multiply those two, what do we get? X squared minus 1 raised half multiplied by x squared minus 1 raised half. X squared minus 1
Because remember, when we talk about the next half.
minus x squared. So x squared minus 1 minus x squared, combine the numerators. Get rid of those two. Yes,
Yep.
denominator is x squared minus 1. So that, I'm going to erase the UV part. Finally, we get y prime to be equal to -1. Over x squared minus 1 raised 1/2 divided by x squared minus 1. How do we simplify that? Right, you just flip and multiply. So you would end up getting -1 over x squared minus 1 raised 1/2 times x squared minus 1. So the final answer is -1 divided by x squared minus 1 raised 3/2.
So what happens?
Yes.
Good question, Sarah. We're going to get that in a bit. Good.
Don't touch.
On when you do MyLab or on the exam, that's not going to be the answer. This is going to be the answer.
Oh my God. So why don't you start with that?
Oh, really?
To illustrate that sometimes you should change an implicit curve to a function of x.
You know what I say to that? The calculator can do it for you if you plug in a function. You can just plug this into the calculator using the math table. All the pain goes away.
So you know what I say to that?
Calculus
I can give
two.
you an F right now.
Oh, no, dude, I'm just saying.
You have no proof.
If I did it and I wanted to check myself.
Don't
Yes,
listen to
online.
me.
Uh,
So, okay, going back to how do we go from, that to this? Once again, back substitution. When you did implicit differentiation, you got this answer, correct? Go back to the original question. What is square root of x squared plus y squared? xy, right? So I can replace the numerator square root of x squared plus y squared as xy.
Oh,
So this is a different way of doing it, so why are we getting a different answer?
That is
explaining.
So divided by x multiplied by xy minus y. Good? Yes. So in the numerator, what do we have in common? Just x, right? So you have x times x minus y. Correct? In the denominator, what do we have in common? xy,
I don't know.
y here, y there, y in common. Correct? So if I pull y out, what do I have left? X.
because x times x.
Wait, how are we starting this? I'm sorry, I just wanna-
Hold on 1 second. That's 1 minus y squared divided by x squared. Good.
Wait, so how did that last part happen? I was writing down.
I'm just pulling out the x in the numerator and y from the denominator. Good. Now, go back to that part. Remember when I rewrote the expression by squaring on both sides, solving for y? That was my original expression, correct? Going to erase this. So first step, I rewrote the square root of x squared plus y in my final derivative with what was given in the question. Second, I rewrote y purely in terms of x. So I got that expression. I'm going to cut that in there. So y prime would be equal to x multiplied by 1 minus y squared. That would be x squared over x squared minus 1. Do you agree? The root and the square will get cancelled. Same in the denominator. Do you agree? Yes. So x over square root of x squared minus 1 times x squared minus 1. Good. There is an x in the numerator, x in the denominator. Those two will get cancelled. Yes. X squared minus 1, that has a power of 1. You're dividing by x squared minus 1 raised half. What would the denominator reduce to? 1 half.
X squared minus 1 raised to.
X squared minus 1 raised 1 half. Good. With me. How do we combine the numerators?
Combine the denominators.
Multiply and divide by x squared minus 1. Have a common denominator. So what do we do to the numerator?
Combine.
Combine them. So x squared minus 1 minus x squared over x squared minus 1 divided by x squared minus 1 raised 1 half. Yes?
That's an existing.
X squared will get cancelled. So you will end up getting minus 1 over x squared minus 1 over x squared minus 1 raised 1 half. We have seen this step before. Right? So all I'm trying to say is if you can convert an implicit equation to a purely function of x, that is the approach that you should take, because it's relatively easier compared to going through the derivatives, then going back and replacing the function. On an exam or my lab, the answer will be that. And it will not be that. So here is my question. Given the option to convert it at the very beginning, then finding the derivative to get that, or use implicit derivatives, then do all the substitutions, and finally get at the answer. Which way would you take?
Second one.
It's a split result. So I personally would go for the second approach, where I will take y, convert it to a function of x, then proceed with finding the derivative.
You